large mass of ocean water moving over a long distance is called ocean water. Like in shorelines, sorry?
Circulation mix of energy,
Heat. So first is heat. 1/3 of total heat transfer. 2/3 is done by wind, atmospheric circulation. So 1/3 of total. So obviously its role in heat budget as well. Very, very important. Then second is weather effect or effect on the especially coastal climate. Then as a nutrient supplier, supports variety of biotic community because of this basically nutrient supplier. So that ways you can club to form a better introduction. Types. On the basis of temperature, it may be warm and cold. It's very comparative as compared to surrounding area. Basically, poleward movement. Then we have equatorward movement. The second is on the basis of speed, that is drift, current and stream, increasing speed. Then on the basis of depth of the ocean water, we have surface current, and then we have deep sea current. Both up till 100 meters, 100 to 200 meters roughly, that is basically above the Pinnock line. Deep sea current is below Pinnock line. Also called thermohaline circulation. Is associated with gravity or basically density driven. Density is affected by temperature and salinity. That's why it is also called thermohaline circulation. Here you have the importance of TS diagram that is shown through temperature salinity diagram. %90 of ocean circulation, 10% of ocean circulation. This is by multiple factors. Here we have the concept of Ekman transport or Ekman spiral and Ekman transport. Warm and cold, a relative term as compared to the surrounding area. That means if the temperature of the flowing water is higher than the surrounding area, it is warm. If it is colder than the surrounding area, it is cold current. Right? Warm generally move away from the equator, then cold generally move towards the equator. Then you have the term upwelling and downwelling. Upwelling is the upward movement of water from below, basically a vertical movement. Affected by, first is offshore winds, prime reason, frictional drag. Then second is sharp bend inward along the coast. For example, like the best example is Africa. Inward means when the current is moving in this direction, here you will have upwelling. Reason you can imagine this? For example, let's see in Africa, right? If the current is, this is the equator, right? This is the equator. When the wind is moving in this direction, so the flow of current will be southward along the coast, right? So it is moving like this. Now this area will not be affected by that wind. So what will happen? Wind will be moving the water slightly away from the coastal area. So if you remove the water, let's say suppose this is the outer boundary of any pan of water and we are removing the water from here. So ultimately the water will move along the gravity, because of gravity. The sea level will be slightly higher, just for the time being you can think of, slightly higher the water will move. So this water will be compensated from water coming from below, right? So sharp inward bend. When we say inward, it is along the wind direction. That will be associated with the upwelling. Again, outward bend, downwelling. Wherever there is accumulation of water, that will result into downwelling, and if there is a removal of water, upwelling. चंदन का फेस कुछ और बोल रहा है, समझ में आ रहा है, right? The third one is the presence of land form below the water, right? So current direction side will experience upwelling. ये नहीं समझ में आया? Let's say suppose this is the sea level, right? And you have a table mount like features here. What will happen? The water will move in all the direction. Here they'll rise, upwelling. Opposite side, downwelling.
Sir, but when we read offshore and onshore winds, it's piling up of air when there is obstruction. Then यहाँ पे pile up नहीं होगा.
किस चीज का?
जब onshore पढ़ते हैं तो होता है कि कॉन्टिनेंट के पास में pile up होगा.
ठीक है.
Downwelling. तो जब करंट सामने obstruction आ रहा है due to that landform.
हाँ. So if the current is obstructed in this direction, so ultimately current has no option but to rise.
Pile up का
यहाँ pile up यहाँ पे नहीं होगा ना. Pile up भी होगा तो भी pile up is below. If the pile up is on the surface, right, then it will downwell. If the pile up is somewhere below, right, so because of gravity and density differentiation, they will not be able to move downward. Rather, they will come up. Right, the surface water is generally lighter as compared to the deep sea water. Then, absence of Pycnock line. I hope you remember especially in the higher latitude, the isothermal column is there, right? Column will have roughly similar temperature. So there will be absence of Pycnock line. And if there is absence of Pycnock line, then there will be mixing. Exactly opposite case will be downwelling. Factors affecting surface current or surface movement. The most dominant factor is wind. Right? Initiates the movement of the current along offshore zone through frictional drag. Right? That frictional drag, hope we understand. Right? When along the continent, let's say suppose it is the continental area and we have the oceans here. Now the wind mass will move like this. Right? Here water will be pushed downward right? Forced to move away from the continent called frictional drag. Right? Now, hardly 2% of total energy of wind is used in frictional drag. Drag will produce upwelling resulting into cold currents always. जहाँ पे भी दिक्कत हो रही है बात करते चलेंगे हम लोग. Right? Only the uppermost part will be directly affected by the wind. No doubt, right? Only upper part, even the not the whole circulation. Below that, the tensional force, that is surface tension of water, I hope you understand, will drag the water below it. Any doubt?
So, drag, in the first line you have written whatever they push downwards.
This pushed, right? And then pushed, the option is this.
How come upwelling?
Okay, how come upwelling will take place in that area? Right. So water will be pushed down, right? For example, if you are, let's just jump in the water, right? When you're jumping in the water, so you are replacing the water of that area, right? And now the water replaced will move in one direction. So once you leave that area doesn't have a depression, right? So ultimately that area has to be covered up. So there are two options. Either the surface water come and accumulate and cover that, or the water from below. The only two options are there. Now, when a single person is jumping, this is occupying hardly a few centimeter area, right? If the wind is coming, there are kilometers, right, along the coastal area. Just imagine trade wind. So trade wind, when it is descending along the coast, that is covering hundreds of kilometers. So the options for surface compensation is limited only in the marginal part, right? So what is the only option left is upwelling. And whenever the water upwells, that means the water is coming from below the surface, and then it is moving on as the surface current. So this will always be having lower temperature than the surrounding area. So that's why cold ocean currents. What surface tension water का पता नहीं है?
Drag the water below it.
इंजीनियर हो ना तुम? या खुदा. देखो हमारे देश का क्या हाल है और क्यों है. कैमरे वाले भी देखो. इनको सरफेस टेंशन पता नहीं है, एंड ही इज एन इंजीनियर. इसका नाम विक्रम है. ये भी देख लेना. कभी लवासना में मिले तो इसको पूछना तुम लोग. विक्रम गुजर पुराना। हाँ, उसके बाद पब्लिश करेंगे इसका कि इसको सरफेस टेंशन पता नहीं था। How will you explain surface tension, by the way? Engineer number 2. If you throw any stone in the water, water hits a particular point, but it jolts good number of area. What is that?
Surface पे potential force लग रहा है along the surface. That is surface tension. Then how will it drag the water below it?
Obviously, when the water is moving, the frictional force will be generated here, right, by the wind. When the water, let's suppose I am putting my hand and removing the water. So when the water which is being removed, that will hit this bottom area also, the next layer also, the next layer also, though the energy transferred will be decreasing. But the water much deeper below, other than which is directly hit or affected by wind, will be affected.
Like the effect of frictional drag, right?
Yes, the topmost will be frictional drag, because the surface currents are generally associated or covering 100-meter deep areas, right? So the entire 100 meter is not removed by wind. एक जनरल डिस्कशन में हम बोल देते हैं कि 100 meter surface current is produced by wind. Only top layer of that 100 meter, maybe hardly 10-20 meters, will be affected directly by wind, removed by wind. But thereafter, it is the water which will keep on affecting each and every layer below. And the removal of water, the energy transfer will be slightly lower side. But since the bottom is removed by water itself, they are much heavier. So the effect will be larger. Can you understand? Now, water is heavier than wind, right? So when the water is heavier than wind, the direction of water movement on the top is far more angular than wind itself. Roughly around top is 45 degree from the wind direction. Can we understand it? Right? उसी पे इसीलिए मैंने मिटाया है इसको. Let's say suppose this is the direction of the wind. Wind is much lighter as compared to water. So once the water has been removed, now the Coriolis force will apply, right? So when the wind is moving in this direction, the actual circulation of water will be 45 degree to the wind direction. Because water is very heavy. So wind, whatever direction wind has attained, the water will not be moving in the same direction because of difference between their weight. So water will move slightly angular, right in the northern hemisphere and left in the southern hemisphere. That is the topmost layer. And the second layer will be moving slightly far more. Third layer will be far more. Fourth layer will be far more. And there will be actual transport will be, this is what you call Ekman spiral. This was first explained by Ekman. Fred Ekman. That's what is called Ekman spiral. For example, let's say suppose this is the wind direction. So the water on the surface will move slightly bigger angle. And then the next layer will be on the more angle, third more angle, and the angle of the water will keep on increasing with respect to wind direction. And that's how the actual transport takes place at roughly around 90 degree below the surface. And this is what you call Ekman transport. When the water moves at, the overall water moves at 90 degree from the wind direction, that is called Ekman transport.
So the speed of the wind matters when
Yes.
angular coverage.
If the wind speed is more, like for example in a very strong wind or very strong upwelling, the direction will keep on increasing. And ultimately what happens, sometimes below, the water moves against the direction of the wind. Exactly opposite to the wind direction. That's how compensated and subsurface current is generated as a local loop. It's possible. Like for example, the angle if keep on increasing. It's not necessary that right there on the point when the water has been removed. Now the water is affecting, waves are generated, so that wave will affect slightly deeper water. So what will happen when the angle is increasing, after a point of time they will reverse below. So that's how it will be compensated. A loop will be created on the surface current, and that's what you call surface current and subsurface current above the Peconoke line itself. आसान नहीं है मुसलमान होना. हर विंड का डायरेक्शन इक्वेटर की तरफ थोड़ी होगा, ट्रेड विंड्स का हो गया. ठीक है, let's say in the case of trade wind, when the wind is forcing the water to move, right? Now a very generalized explanation is that only the coastal area will affect the upwelling and downwelling. That is in GS part, right? But when you go deeper inside, it's not necessary that the coastal upwelling and coastal downwelling takes place. Even in the middle of the ocean you can have divergence and convergence. Now what happens here when the water is being removed, right? So water is being compensated from below. Now the surface current will be moving thousands of kilometers away, right? Now just imagine, so with this Atlantic Ocean, let's say North Atlantic Ocean. So if the water is being removed and sent to Atlantic Ocean, so there is a continuous removal of water. So the eastern portion of Atlantic Ocean should be having deficiency of water, and western coastal area should have a lot of accumulation of water. And if this water which is being sent from here is not being compensated, then the depth of the ocean water, the water will be completely removed or wiped out from the eastern coast. So it has to be compensated, just like the case of wind we have discussed. Water is limited in quantity, and if the water is being continuously removed from here, the water which is being sent must come back to this region. So basically, when the water from the surface is being sent along the coastal area, this will be accumulation, and the sea level will be higher by 2 meters, 3 meters or so as compared to this. Now a gravity differentiation is created, so the water should reverse on the surface, but that is not the case. Exceptions is El Nino, but that's generally they'll downwell and they'll compensate through subsurface water. That's how a loop will be created. Now that loop in general is associated with coast to coast. That is the older explanation. But nowadays that upwelling and downwelling may be in the middle of the ocean, and a local loop, a small local loop can be created within the ocean itself. Getting that point? That water has to be compensated, and compensation can be done only by making a circular loop or semicircular or roughly circular loops or rectangular loops. Right? That loop we are talking about, the subsurface is basically exactly in the opposite direction of the wind, and that separates the surface current and subsurface current if it is properly evolved. Otherwise, if it is not properly evolved, it will be compensated through Ekman spiral. Now, along the trade wind belt, eastern coast of ocean, offshore wind, we have already seen that, will lead to upwelling, will lead to formation of cold ocean currents all over the world. Because wind is the most important and the most fundamental reason for upwelling or downwelling. The western coast of the ocean, accumulation of water, rise in sea level. Here you write offshore also, onshore, rise in sea level, downwelling, associated with warm currents. Wind in the westerlies belt, eastern coast of the ocean, will be onshore. Exactly opposite. Downwelling, warm ocean current. Western coast of the ocean, offshore, upwelling, cold ocean current. Beautiful. That will affect the ocean currents. The best is seen in North Indian Ocean. If the wind direction is changing, there will be a corresponding change in the direction of ocean currents as well. That's why wind is the most fundamental reason for the surface circulation. तो हमेशा से विंड भी वहाँ पे वही बहती होंगी, तो ओशन करंट की भी शिफ्टिंग थोड़ी ज्यादा होगी. Ultimately, the waves are generated by wind only, right? The currents will move also in the direction of the wind, not in opposite direction of the wind, especially the surface current. In the polar easterlies belt, situation will be similar to that of trade wind belt. Hope we are getting it. Polar easterlies, the direction of the polar easterlies will be similar to that of trade wind. The second factor is the Coriolis force. Or if you want to continue with the wind, like for example last year there was a question directly on this. The wind is an important source of ocean currents visible in the North Indian Ocean. Explain. So the best scene is North Indian Ocean with the monsoon currents. We'll see that. Then scene is western coast of Northern Africa in the form of Canary Current, which is warm and cold alternatively seasonally. Shifting of pressure belts is not quickly affecting the shifting of ocean current belts, basically because ocean currents are much heavier and they may not respond very easily to the wind. It has to have a consistent flow for good long duration, only then it will be affected. Coriolis force affects the direction, makes the circulation roughly circular, right? Clockwise, northern hemisphere, counterclockwise, southern hemisphere. A hypothetical continent, take equator, the circulation will be roughly like this in the northern hemisphere, like this in the southern hemisphere. Because of this, the ocean water flows making a circular or roughly oval loop, which is called gyre. Two types of gyre: subtropical, which is more prominent, subtropical gyre, and subpolar gyre. Very prominent, found in every ocean. Less present. Then we have circumpolar gyre, most developed in Antarctic. The perfect circular gyre or loop is created in Antarctic. Each gyre has 4 components. Eastern component, western component, equatorward component, poleward component. The strongest of all because of increasing Coriolis force. Because of greater accumulation of water. equatorward component creates equatorial current. Eastward is under the influence of trade wind. Westward is under the influence of westerlies. The middle part, roughly the middle part of the gyre has hills of water with rising sea level because of accumulation of water. That creates gravity slope. The water moves down slope, but Coriolis force balances it, and the resultant direction is circular, making the flow gradient or geostrophic. Yes, that's the whole is jet, circular loop. Let's see, suppose, let's say in the northern this continent, so the trade wind will make the this is this, right? Now the air which is hitting will have a roughly an area which is covering it, right? Especially with respect to water, because the coastal effect on water is also an important factor affecting the direction. Now when the area is being affected, let's say suppose this much area is actually being affected, directly being affected by the wind. Now when the water is moving, this side it will be moving. Suppose this is the width along which water is moving. So the every moving fluids will have, one is linear force, another is sideward force as well. रिवर्स के केस में याद करो, एक है vertical erosion, एक है lateral erosion, right? Right. The slope determines that. That's a different case. Here you don't have that strong slopes to create a vertical erosion or vertical movement. When the water is moving, they'll have both the outflow, centrifugal force, right? So the water will from each side will supply the central part, right? And that's how a semicircular or roughly circular location and hilly portion, where the water sea level will be rising. Now the water will move downhill, right? But this water is basically, the creation itself is associated with Coriolis force or pushing sideward. So एक चीज इधर से भेज रही है, दूसरी चीज वही वापस आना चाह रही है. So जब बैलेंस हो जाएगा तो मूवमेंट क्या हो जाएगा? Ultimately the actual ocean circulation along this gyre will be roughly around circular. That will be clockwise in the northern hemisphere and anti-clockwise. That will be very, very slow as compared to the loop of the gyre. This is the pure loop of the gyre, right? This is the eastern component. This is the western component. This will be poleward component. This will be equatorward component.
So it will be traveling only large oceans or it will be there in the small oceans also?
In the large ocean, that phenomena will be slightly weakened. In the very small ocean, that will not be existing. Especially when it is, like for example, we have discussed about the El Nino, that the the Coriolis force will have its outermost boundary or the maximum possible area which it can cover. Beyond that, it will not be able to cover. So that loop will be gradually broken. That results into the formation of El Nino or La Nina or Indian Ocean Dipole or North Atlantic Oscillation. All these are associated with that. So Atlantic presents relatively a perfect area which creates those loops.
So it means that this placement, the present placement of continents also drives the ocean currents. Had it been Pangaea as a single landmass, so that movement would have been never there.
Yes, it would have been there. Atmospheric circulation is there, but the way it is being distorted because of the presence or absence of continents would not have been there. It would have been more linear, much broader, and much more specified than what you expect in the present day situation. Like for example, in the South Ocean, where land masses are absent, the currents are not absent. You do have currents, but much more linear currents are found there, because the strong frictional drag will not be there. And wherever we have strong frictional drag, then that is affected purely by the presence of continents, especially along the offshore. When you have a strong accumulation also, a strong divergence, right? For example, the oceanic, the coast shape is like this. So then that shape of the coast will be that's the third factor we are going to discuss affecting the ocean current. Shape of the coast. Once formed, the ocean currents gets aligned with the coastal topography. The curves, especially the strong one of the coast, affect the currents in many ways. Speed, right? Direction, upwelling, downwelling. All are affected by the shape of the coast. For example, the only occasion where South Equatorial Current, South Atlantic Current is forced to move and merge with North Atlantic Current along the coast of Brazil. Hopefully we can say integrate that. Look at here, this is roughly the shape of Brazil, and then equator roughly passes very close to this. North equatorial current, South equatorial current, one is bifurcated, another one moves and merges with this, making a much stronger flow. Similarly, everywhere, like for example, Caribbean Sea, South China Sea, Japan Sea, the Indian Oceans, presence of Madagascar Island, presence of peninsular tip of India, all have affected the direction of the ocean currents. अभी बताए थे ना वो जैसे shape वाला, sharp bending है. Like for example, if the bending is very sharp, we have already seen that. Inward, if the wind is coming in this direction. If bending is like this and wind is coming in this direction, so there will be a lot of accumulation of water, so there will be downwelling. Here it will be upwelling. Hope we can understand. The moment water is accumulated, the sea level is rising and accumulated because of wind direction. So the wind is forcing the water to move. Now at that wall, if the water is being accumulated, there are only two options. The same can come towards the wind, but the surface flow is basically produced because of this. So they cannot really come in the opposite direction of the wind on the surface, so they will downwell. Next factor is the salinity. Now we are talking about surface variation in salinity. Across the oceans. That means basically intra-oceanic circulation. As the salinity affects density, right? The density will affect depth, or basically the local level, sea level, right? Sea level, this will create gravity slope, and the gravity slope, the water will flow along the slope. Density? Density, like if salinity is higher, so the density will be more. Because more density means more compact, So sea level will be slightly lower. There will be very little variation, and that little variation will be large enough to produce the even a small slope. The best example is Mediterranean Sea. The flow within the Mediterranean Sea now, eastern Mediterranean is much drier. Drier means high temperature, means high salinity relatively. High salinity means lower sea level. The surface current west to east. Clear है? Caspian Sea, for similar reason, surface current south to north. Volga draining into that, relatively lesser temperature in the North Caspian. So obviously the temperature and salinity is affected. So the local level circulation will be very severely affected by the salinity. Now salinity, temperature and resultant density affects the and produce what we call thermohaline circulation, primarily associated with deep sea. Temperature is the prime reason for density in lower latitude. Salinity is the main reason for density in higher latitude. Dry areas, Israel, West Asia का पार्ट है, वो सब पूरा लेबनान एंड ऑल, डेजर्ट्स हैं वहाँ पे, ट्रेड विंड्स बेल्ट है, सब ट्रॉपिकल प्रेशर बेल्ट है. The shifting of pressure belt will also not affect that much. So they are drier areas. Dry areas on the similar latitude will always be warmer, especially in the within the tropics or subtropics. Density is lower. Sorry, temperature density produces thermohaline circulation along deep sea. This deep sea current की जो हम बात कर रहे थे, शुरुआत में ही हमने बात करी है कि deep sea current is affected by the temperature salinity, especially lower latitude, higher latitude. Temperature is the main reason for density variation in the lower latitude. Higher temperature, lower density, lower temperature, higher density. Similarly, salinity is a more important reason behind density variation in the higher latitude, because higher latitude have isothermal column, right? Because the higher latitude have isothermal column, and because of isothermal column, the density will be affected by salinity. Here you have thermocline present. Their thermocline is absent, yet there will be density variation associated with salinity, and that's how it is shown through what we call TS diagram, temperature salinity diagram. Let's have a look at that. We can see this. We can make this diagram also. Look at that increasing temperature and then increasing salinity, and then the lines of equal density. Picnoc line is what? Zone, where with changing, rapidly changing density, it is the isolines, equal lines. This is not isohaline. This is gravity. This is associated with density, right? So look at here, salinity, how salinity is changing. Roughly it is shown from 33.5 to 36.5, and when the temperature is moving towards 20. Look at here, low salinity and low temperature producing low level of density. Now look at the irony here. High salinity, low temperature producing relatively high density, because here density is affecting salinity. Even in the lower temperature area, if the higher density is there, higher salinity is there, the density may be higher. That's what we were talking about. If the temperature is high, the density will definitely be low. If the temperature is low, density may not necessarily be low. If we are getting that, that is how thermohaline circulation is created, and that is how deep sea currents are created. So deep sea currents, first you make it, we'll discuss that. The difference is so minor, you can see, in density. It's starting from 1.024 and it's ending with 1.025, 029. Hardly 0.005 difference, 0.005 ka difference was. That is large enough to create density variation. right? Now you see the subsurface, the deep sea current will not be initiated in the lower latitudes, because the thermohaline situation is very well developed in the higher latitudes because of the presence of isothermal lines, right? If you look at the thermohaline, which one is more visible? Thermohaline circulation, that is deep sea circulation, is initiated in the along the high latitudinal belt. Why? Because there is an absence of pycnoplane or presence of isothermal column. So for any reason, if in the high latitude the density is higher, right, because of salinity, then that high density water will sink below and they will initiate the flow, and the deep water flow is very slow, 10 to 20 kilometers per year. That is roughly around the per hour speed of most of the surface currents, right? So it is very slow, but since the mass, 90% of the ocean water mass is affected by deep sea circulation, this plays a very important role in overall mixing of the ocean water, and that is how the salinity is distributed and redistributed because of deep sea circulation. So this you can talk when you are talking about salinity also. This you can give an example in your introduction, that how the ocean currents affect the salinity also. You can see this thermohaline circulation, and you can make this diagram as well. Because thermohaline circulation may be a separate question of 150 words. Remember it. This is the gyre formation in North Atlantic Ocean. This is subtropical gyre, and you can see the circulation as cold and warm. उसमें एक्सप्लेन करने के लिए कुछ था क्या? Okay. Let's see that. Look at here, the temperature is lower, and because of any reason, if the salinity is higher, right? Let's say accumulation of snow, less melting of snow, or less water surface. So what will happen? The surface water will be having much higher density, and because of that, they will gradually drift, very slowly sink, and the sink, then the bottom, and then somewhere it will create upwelling in the surface current, and this combined effect of all. And this second, this is a convergence zone basically, the subpolar, like Antarctic polar front. So frontal zone there will be convergence, and because of convergence there will be subsidence. When the water is converging, there will be subsidence. Just like when the air is converging, there will be rise of air, but water is converging, there will be downwelling. and that downwelling will result into again deep sea current. That's intermediate current, and this is bottom current. Here in this region, again because of the surface condition and plus the water which is moving here. Now the zone is lying in between. This is westerly belt, right? So in the westerlies belt, when the water is being removed from the surface, there will be upwelling. This is the normal circulation, and that upwelling will support that removal of water on the surface will support the upwelling. Here you don't have Picnock line, right? And because of that there will be upwelling. Is it fine? Look at the gyre formation and the geostrophic circulation, geostrophic current, that is moving circular clockwise in the northern hemisphere, anti-clockwise in the southern hemisphere, right? The central portion will be slightly elevated. It is highly exaggerated the way it is shown here. This will not be in the actual case. The slightly lower, but yet it is will be sufficient to generate a gravity slope. And when the water is flowing, and that, look at here, the center of the gyre will not be exactly in the center of that because of intensification of western counterpart or component of the gyre. Here the zone is trade wind. Let's say subtropical gyre if we are talking about. This is the zone of trade wind. And now in the trade wind zone, when the water is moving towards the equator, the Coriolis force will be slightly lesser. And when it is moving towards the pole, the Coriolis force will increase in the moving direction. And that's why the intensification of western, that's why western component will be much more stronger, in fact the strongest of all the components. The effect of ocean current. First, as a source of balancing the north-south energy imbalance created by insolation. That is its role in energy transfer or heat budget. When warm water moves from equator towards the pole, it transfers the energy towards the pole, and the cold water moves from the pole towards equator. Again there is a transfer, exchange of energy, and that exchange of energy again is in the form of budgets, what you call heat budget of ocean. Just like that of the atmospheric circulation on the continent. When we talk about heat budget, the similar pattern will be there. The only difference will be the extremes of temperature will not be existing in the oceans. There will be roughly uniform distribution of temperature in the middle of the ocean, but along the coastal area the temperature will be relatively higher and lower depending upon the presence and absence of cold and warm ocean current. And if the cold and warm ocean currents are not present, the temperature will rise and temperature will decrease depending upon the latitude. Lower latitude, the presence of continent will ensure relatively higher temperature, and higher latitude the temperature will be lower. Simple as that. Right? The second, its impact on climate, very dominant impact on climate. First, the warm ocean current increases the temperature of the area, right? So if it is present in the cyclonic zone, it will intensify it. Right? Warm ocean current has greater capacity to absorb moisture, hence associated with higher rainfall. That is further complemented by the fact that they are found in the onshore zones. Onshore zones are having much greater probability of rainfall, and that is further intensified by the presence of warm ocean current. Its presence in the higher latitude ensures warming effect and has positive role to play not only with respect to humans but also over biodiversity. Not necessarily fishing grounds. Fishing grounds are not associated with warm temperature. Basically, it is associated with when the temperature is on the higher side, not higher that of tropical region. So temperature, if warm ocean current is moving in the colder areas, then the temperature is slightly moderate, and moderate temperatures are more suitable for the variety of species. Extremes of temperatures are not tolerated by a species, whether it is too cold or too warm. So warm water in the tropical zone. In the tropical zone, negative impact. In the higher latitudes, positive impact. Best example for this is the West European coast, especially even Norway, Sweden, north of Russia also, where the presence of North Atlantic drift keeps the coastal area warmer and more livable as compared to any other area located on the similar latitude. For example, Murmansk in Russia is the only port remains ice free throughout the year. At that latitude, again because of presence of North Atlantic drift. Similar case will be Kuroshio current in Japan, plays a very significant role in northern Japan. Then we have effect of El Nino as a negative impact, because that warm ocean current is generated in the tropical region. So almost all the negative impact associated with high temperature is correlated with El Nino. Effects of ocean current over pressure, wind and rainfall can easily be explained and correlated. Warm ocean current, low pressure. Cold ocean current, high pressure. For example, the eastern coast of America, warm ocean current doesn't allow the high pressure, especially the Bermuda, I hope we can correlate, to enlarge. Then biodiversity. The upwelling enriches the nutrient supply. Nutrient supply becomes more important. Fishing grounds. Downwelling, oxygen supply. Convergence zone, plankton formation, again fishing grounds. Convergence create fogs, dangerous for navigation. You can mention here cold wall along the convergence of Labrador and Gulf Stream. Cold wall is the name of that zone, the wall created by fog, which is very dense and very thick and very great height. That is called cold wall. That is disappearance of ship is present in modern day में अब नहीं कह सकते हैं वैसा. Earlier it used to create problem. That ship disappearance is associated with Bermuda Triangle. It's still a mysterious thing. हर चीज हम लोग समझ जाएंगे तो फिर ऊपर वाले को भूल जाएंगे ना, साफ भूल जाएंगे. इससे तो बहुत ज़्यादा भूल नहीं लगे हैं, लेकिन साफ भूल जाएंगे. तो वो भी अपनी हरकतें दिखाता रहता है ना कभी न कभी कि औकात में हैं. हाँ, मतलब दिखाता रहता है कि औकात है तो दिखाओ. Right? Then here the supply of nutrients in the far middle of the ocean. from the coastal areas. That is distribution, redistribution. Coastal areas are the more important areas for nutrients. So the ocean currents supply into the deeper water. That becomes the source for larger animals which are found in the middle of the oceans. Currents of Atlantic Ocean. Open the atlas. And remember one thing, suppose we have already had the basic concepts. If the questions are asked, describe the important currents of Atlantic Ocean, you simply need to explain and its role. Discuss the present reasoned account of the currents of Atlantic Ocean. Reasoned account, then why they are originating. You will have to talk about that, remember it. Right? एक तो simple है explanation or description, describe the currents of a particular ocean, any ocean. So you simply make a diagram and make that how circular pollution, effect of Coriolis force, and what are the different currents which are present. Present a reasoned account. Explain all the reasons. Together with accounting. Ocean currents. Right? Third question may be the effect of ocean current of a particular ocean. This will be purely associated with either Atlantic, more with Pacific. Indian Ocean में ये क्वेश्चन नहीं पूछेगा. Pacific में फिर एल निनो की बात करेंगे. Atlantic में गल्फ स्ट्रीम एंड ऑल उसकी बात करते हैं, किस तरह से क्लाइमेट पे इफेक्ट है, किस तरह से बायोडाइवर्सिटी पे इफेक्ट है. सेम वही चीज जो हमने इफेक्ट ऑफ ओशन करंट्स को देखा है, उसको किसी पर्टिकुलर ओशन करंट्स के ओशंस के बारे में बात कर लेंगे. First we'll see the Atlantic Ocean current. In sequential order, we'll go to first the Venezuela current. Produced because of offshore trade wind. The trade wind will be offshore here, right? Offshore trade wind. It is basically produced because of the offshore trade wind, and then this is what you call South Atlantic drift. This is South Atlantic drift. Then Venezuela current will move towards equator, right? That will become south equatorial current. South equatorial current roughly covers 0 to 20 degree latitude, 0 to 20 degree south. Here you have south equatorial current. It is simply continuation of Venezuela current, turning leftward under the influence of Coriolis force, right? Now part of south equatorial current will bend, will move southward as Brazil current, and some part will move north of equator. You can see that north of equator, and then in north of equator it will merge with the north equatorial current, that is North Atlantic current. Extension of Canary current, this will cover 0 to 10 degree north latitude. North equatorial current covering 0 to 10 degree north latitude, south covering 0 to 20 degree south latitude. Yes. North equatorial current here, right? And they'll move like this, not become Gulf Stream. First it will move, and then some part will enter into Caribbean Sea called Caribbean current. And the north of, east of this island, it is moving is Antilles current. Antilles, Antilles current. This is Antilles current. Antilles, Antilles, Antilles current. And the one which moves inside the Caribbean Sea, it becomes Caribbean current, and then will move in this direction and will come here, and they will be known as Florida current. The Florida current is known as from Florida till Cape Hatteras. Cape Hatteras, it is known as Florida current. Cape Hatteras to Grand Bank, it is called Gulf Stream. Right? Here it merges with Labrador current, this Labrador current, and because of merger this forms a very important fishing ground, planktons and all we can expect. There you have the formation of cold wall, because the difference in the temperature in Gulf Stream and Labrador current is very high, the highest possible on the surface of the earth. The most studied of all the streams, ocean current, is the Gulf Stream, and this is the fastest and the warmest ocean current in the normal ocean current except El Nino. And because here the fastest, why it is fastest? Because volume is increased from the equator itself, where the south equatorial current crosses and increases the volume by merging with the north equatorial current. Then this Gulf Stream, after convergence with the Labrador, reduces the speed and then moves as North Atlantic drift here. Right, look at the Greenland current, again is a polar easterlies, right? And this is the cold ocean current. North Atlantic drift moves in the direction, some part of North Atlantic drift will have three parts of North Atlantic drift. North Atlantic drift, we have this branch, northwest branch, that moves in the west. बहुत सारे नाम है इसके, उसमें जाना नहीं है. जो यहाँ पे आ रहा है, ये वाला part, right? That is North Sea branch, which moves along Bay of Biscay, ultimately merges to strengthen the Canary current. Canary current is the most important current affected by the shifting of pressure belts. During summer, it comes under the influence of trade wind offshore, becoming cold. During winter, the area comes under the westerlies onshore, warm current. And this is the subtropical gyre. Northern gyre is also called Columbus gyre. This portion is called Columbus gyre. And here the land is so perfectly located that it creates the most perfect gyre of the oceans, all the oceans. And the central portion has a very calm water, and supply of nutrients from all the sides enriches the formation of seaweeds. That seaweeds is called Sargasso, and here you have Sargasso Sea. This is North Atlantic Ocean, we have Sargasso Sea. No, that is again warm because they are extension of North Atlantic drift only. It is moving under the influence of Coriolis force and coastline. Look at here, this is shown in a single line, but this will not be a single line, this will be a belt where the ocean water is flowing. Now along the coast of England, this portion of Britain where it is being affected, that will move along this, and good part will be affected by Norway coast, so that will move into North Sea. One will move North Sea and one will move along the south of Britain. That will remain warm because they are just extension of North Atlantic drift, right? And that area is having colder water as compared to this has North Atlantic drift is warm basically because extension of Gulf Stream, right? And its temperature will be relatively lesser as compared to Gulf Stream because of the convergence, not only the speed but the temperature will also be affected, right? So the different portions will be a warm ocean current unless until it merges with Canary current. That is circular loop or gyre which is being formed, subtropical gyre. Here you have again subtropical gyre. Brazilian current will be met here by, which is not shown here properly, Falkland current. You can see there in the atlas. Falkland current is a cold ocean current, then result into sharp deviation and bending of Brazil current, and that will become west wind drift or South Atlantic drift. Yes, fishing grounds. But here the exception is that Argentina is a not very important producer of fish, basically because they have good amount of land portion for meat, for basically animal husbandry, and most of them are more meat eater than fish eater. Only nowadays it is being developed basically for export purpose. So we have Venezuela, Falkland as cold current, rest as warm current except west wind drift. Here you have Labrador, Canary as cold current, rest are warm ocean current. Now here you explain north equatorial current, south equatorial current, then counter equatorial current. Counter equatorial current is produced because of the convergence of the two currents in the middle and the western part, and under the influence of equatorial westerlies they move eastward. The counter ये हम बात कर चुके हैं, इसलिए मैं फास्ट हो रहा हूँ. जब हम विंड की बात कर रहे थे तो वेस्ट इक्वेटोरियल वेस्टर्लीज की बात की थी. When the trade wind converges, so because of the convergence, a great portion of the converging air mass will rise upward, but on the ground there will be a counter movement in the middle of the convergence zone because of the direction. So in the middle of the convergence zone, in the calm zone, we'll have the wind which will move from west to east, that is equatorial westerlies. Just similar pattern will be there with respect to ocean currents. When the ocean current converges, right, they'll move in this direction or they'll move in this direction, but there will be some column in the middle where they'll move as a counter equatorial current. Not necessarily with this, because of the convergence. Convergence will result into piling up of water, and the piling up of water will first try to move along the gravity slope. And when the north equatorial current and south equatorial current is converging, they have a different direction like this. So piling up of water is here. So they'll move this side, right? But they will be easy to move in this direction, because here the direction of the water flowing, north equatorial current and south equatorial current, is such that the middle portion will be relatively generating a gravity slope. Hope we can explain it. South Atlantic gyre, it is also called navigator gyres. The North Pacific, look at here, the increasing size of Pacific gyre. The South Pacific is much bigger, hence you have a lot of problem here. Though the El Nino type of effect is visible in almost all the oceans, but that is most intense in southern oscillation in the form of South Pacific. Look at here, the equatorial region. Alaska current, this is shown wrongly. Here it is warm current, this portion of Alaska is cold. Here again, because of the best example of upwelling, the inward bending of continents. This circumpolar current is the most developed around the Antarctic. Look at here, in the Pacific Ocean, you will have almost similar pattern. Peru current, you can explain that. Look at here, the circulation here, the smaller gyres. And the gyres are broken into several, which is not there in the Atlantic Ocean. Why? There will be formation of El Nino current. Right? That goes to become South Equatorial current. Then East Australian current, again the trade wind will be onshore, warm ocean current, South Equatorial current, North Equatorial current, Counter Equatorial current. You can explain that. The Counter Equatorial current in Pacific Ocean will not be that strong as compared to Atlantic Ocean. Indian Ocean has altogether a different movement because of monsoon. Then Kuroshio, then Oyashio, this Kamchatka, then that Kamchatka, this Kamchatka Peninsula. Here it is Oyashio current. Oyashio is a cold, Kuroshio is a warm. Oyashio will be produced because of westerlies being offshore here. Kuroshio will be produced because trade wind is onshore here. Trade wind here in California current is offshore. So there will be cold ocean currents. So simple, relatively much better gyre is produced, but the gyre is broken and distorted in South Pacific Ocean because of its vastness. And that creates the oscillation, what you call southern oscillation, and resulting into El Nino formation. Yes, because the vastness of the size, when the continents are not contributing in piling up of water. When the continent is there, then piling up will be much more stronger and sea level will rise very strongly. But here the size of the ocean is so vast, especially in the equatorial region. If you look at here, the farthest in the equatorial region. Okay, then you can explain that South Atlantic circumpolar and Atlantic circumpolar, Antarctic. It's all Antarctic circumpolar. You don't have along the North Pole, because circumpolar in Antarctic is very strong because central part is occupied by again land areas. So that circumpolar current is very well developed, very strong, and supplies huge amount of water in that region. we see Indian Ocean. Currents of Indian Ocean, South Indian Ocean, it will be as simple as the basic concepts we have discussed. Here you look at the only possible is West Australian current. That is a cold ocean current. इसकी स्याही फिसल गई है इसलिए रेड से दिखा रहा है ये. That is a cold ocean current, right? The only well-developed cold ocean current in the Indian Ocean, except that drift वाला part, right? ऑस्ट्रेलिया के पास वेस्ट ऑस्ट्रेलियन आ जाएगा, then it will move as south equatorial current, north equatorial current, counter equatorial current. But during seasonal variation will be very visible. You can see there in the atlas as well. एटलस में जनवरी में अलग दिखाया जा रहा होगा और जून में अलग दिखाया जा रहा होगा. जनवरी में द नॉर्थ इंडियन ओशन इज अफेक्टेड बाय नॉर्थ ईस्ट मॉनसून करंट. जून में इसको साउथ वेस्ट मॉनसून करंट दिखाया जा रहा होगा. राइट, लुक एट द डायरेक्शन, द साउथ वेस्ट मॉनसून करंट. देन इन द this circulation here, you see the movement of air here along Somalia coast. That is where upwelling takes place. That is again inward. You can see the coast also inward. Here upwelling takes place, and during southwest monsoon season, a little bit of area is covered by upwelling, which generates cold ocean currents, and that's where the sometimes these tropical easterly jet stream descends, and it creates much more stronger pressure belt here, and that generates Somali jet from here towards Western Ghat. This is Somali jet area. Look at Agulhas current. You will have Mozambique current also. This side you have Mozambique current. Which is not mentioned here. Write down a question. Write a short notes on deep sea current. Second question, present a reasoned account of the ocean currents of Indian Ocean. Present a reasoned account of the currents of Indian Ocean.